So with continuing with finding zeros for quadratic functions, we're going to look at a sports application here. And here they show the formula negative 16t squared plus v sub 0t plus h sub 0. Now this is talking about a flight of a projectile, like the path of a ball, the path of a bullet, shooting a ball, okay? Somebody punting a football or punting a soccer ball, okay? They all represent those types of things. H of t represents the height after t seconds. Negative 16t squared is gravity in feet per second. If we were using meters, we would have negative 4.9. V sub 0 is the initial velocity of the ball, and h sub 0 is the initial height. So what we're going to be looking at is what are all those values, and then finding the answers they're looking for from there. So this golf ball is hit from ground level with an initial vertical velocity of 80 feet per second. After how many seconds will the ball hit the ground? Anybody watch the Masters this weekend? Any of you big golf fans? Seriously, did you?
No, seriously, I did.
Okay. All right. So I watched a little bit of it yesterday, but that's about it. Okay, so everybody knows what the path of a golf ball looks like, right? Guy hits the golf ball, it goes out, comes back down. All right? So the path of the ball follows somewhat of a parabola, quadratic function. Now, the path of the ball, it always starts at initially, okay, in this case, because he hit it from ground level at time 0, it's at 0. Okay? So we need to find when does it over here hit the ground again? Because it has hit the ground, right? Eventually it's going to come back down. So what we're going to do is we're going to put in the information that they give us into this formula, okay, and then find the zeros. So let's see, h of t equals negative 16t squared. And they tell us the initial velocity is 80 feet per second. So v sub 0 equals 80. So plus 80t. And it says they hit it from ground level. So that means that h sub 0, the original height, is just 0. So do I need to add plus 0 down here on the end? No. Okay, I don't need to put 0 there. So with this function, they want us to find when it hits the ground. So I can do that two ways. I could graph it, okay, or I could factor. So since my calculator is somewhere else, I can't find it right at the moment, I'm going to factor it because I want to know when this equals 0. Okay. So the first thing, remember, when we're factoring is we always want to look to see, do they have something in common? What do these two have in common? They have an 8. Okay. So when you take out the 8, then in this case, I'm also going to take out the negative. Okay. All right. So negative 8. Do they have anything else in common? Oh, Mr. Schroeder says that it's a 16, not an 8. Are you sure? All right. Well, let's go with the 8 for a moment, okay? All right. Let's live with that for the moment. Do they have anything else in common besides the 8? Okay, T. All right. Because not everybody knows that 16 goes into 80, right? Okay. Checking that out with your calculator on your phone there, Nolan? All right, good work. Okay. They also have a t in common. So if I factor out negative 8t, then I have a 2t here plus, or nope, it's going to be minus now because we took out negative 8. And what's 80 divided by 8? 10. Okay. All right, that's all right. equals 0. Right? So I want to know when this equals 0 and when this equals 0. Okay, because maybe you don't know that 16 goes into 80, which is obviously true, which is okay. I can still find the answers. All right, so when does negative 8t equal 0? Okay, when t equals 0, which is this point here. Okay, there's our original. All right, and they hit it off the ground. Okay. All right, so then when does t equal 0 here? All right, so if I solve that equation, right, we would add 10 and divide by 2. So t equals 5. So in this case, that golf ball is going to hit the ground after 5 seconds. I could find that out just by doing some factoring. You could graph it also. So if I had my calculator, I could take out my calculator, go to my y equals negative 16x squared plus 80x. Make sure I'm in a standard viewing window. And here's my graph. Now, I'll look at the table for a moment. We can see that it goes up to about how far? Okay. It shows 96 twice, so actually it goes higher than 96 then, doesn't it? Because there has to be an absolute peak then. Okay. Well, the nice thing about parabolas is that they're symmetrical. So where would be the highest point of this golf ball? At what time? Okay. And Ruth, why is it 2.5 seconds? Okay, it's right in the middle. Okay. Not only is it right in the middle of the two 96s, but it's right in the middle between the two zeros. Okay. So half of 5 is 2.5. So that I know that it's got to be somewhere around 100, so I could change my window to be able to see this. When we're talking about our x-min, do we need any negative values for time? Okay, have you ever gone back in time? Yeah? All right. Well, some people have, I guess. Okay, so I don't need those negative values of time. But our y max is going to be approximately 100. All right, so we graph it, and there it goes, and there's my graph. So I can see 1, 2, 3, 4. After 5 seconds, the ball is going to hit the ground. Okay. I could have done that by factoring or put it in my calculator and look at either the graph or looking at the table. I can see that. Okay. If somebody asked me what the maximum height was, well, I know it's got to be at 2.5 seconds because it's halfway between the two zeros, and that would be at exactly 100 feet. All right. Okay. All right. Let's remember a couple special trinomials that we have, or binomials and trinomials. Right? We call these special products and factors. Just a little reminder about the difference of two squares and perfect square trinomials. And I want to tell you something, that remembering these is very, very important, because almost on a daily basis, I'm talking about those two things in pre-calc and in Algebra C. So if you know them and you realize the little shortcut here, okay, it can be very valuable to you, help you out. So here they want us to find the roots by factoring. So that means that whenever I want to factor to find the solution to a quadratic equation, it's always got to be equal to 0. So for letter A here, the first thing I have to do is get it equal to 0. So what do I have to do to get it equal to 0? Okay, I have to subtract 25. Okay, I got to get everything on the same side, and I want my x squared term, if at all possible, to be positive. So I'm going to subtract 25. So I get 4x squared minus 25 equals 0. Now I can factor it. Okay. Do 4x squared and 25 have anything in common? Okay. Is there a number that goes in the 4 and 25? 1 does. That's right. Okay. Only 1 though. So I can't factor anything out of them. Right? But this is the difference of two squares. So I can factor the difference of two squares. What's squared to make 4x squared? Okay, 2x. And what squared makes 25? Okay, so I have 2x plus 5 and 2x minus 5. So we're going to set those two things equal to 0 and solve. And the nice thing actually about them, when you have the difference of two squares, when you solve them, you really only need to solve one of them, because you're going to get the same number, except they're going to be, one's going to be a positive and the other one's going to be a negative. So we'll subtract 5, divide by 2. So my solutions are going to be x equals a positive or a negative 5 halves. Because if I solve the other one, I'm going to get positive 5 halves. So I get plus or minus 5 halves. Wasn't expecting that. There we go. Okay, letter B. Okay, once again, the first thing we want to do when we have an equation with x squared as our highest degree term is we always want to get it equal to 0 to solve the equation. And I want the x squared term to be positive. So in this case, even though there's only one term on the left side, it's the x squared term, and that's positive, so I want to move the other things over to that side. And I don't want to move the 18x squared, I want to move the 48x and the 32. So I'm going to subtract 48x and add 32 to both sides. Then, like any other time when I'm trying to factor, I want to look to see if they have something in common that I can factor out first. Do 18, 48, and 32 have a number in common? Okay. 2. Okay. Well, 4 goes into 48 and 32, but not 18. Okay. So In this case, I can factor out 2 of everything. Now, since since it's an equation, instead of factoring out 2, I'm going to divide everything by 2 because I want to just completely get rid of it. I don't need it then. So we're going to divide everything by 2. Now, if there was a variable like x included with that 2, then we wouldn't divide. We could just factor it out. But in this case, I want to divide by it. So we get 9x squared minus 24x plus 16 equals 0. So we just got done talking about, or showing you, we've got up here the special products and factors. So we had the difference of 2 squares and perfect square trinomials. Well, if I look at this problem here now, I have a square for my first term, okay, 9x squared, and a square for my last term, 16. So that's a situation where it looks like I might have a perfect square trinomial, which says that I have 3x and 4 that are squared. So if you notice up here, the middle term in each of these two says a negative 2ab or positive 2ab. In other words, if we multiply these two numbers together, a and b, right, and we multiply them by 2, we get the middle term. Okay? So what's 3 times 4 is what? 12. And if I double 12, I get 24. The only thing is here is my 24 needs to be negative, which means my 4 has to be negative. Oops, or a blue one. Okay. So the middle term of a perfect square trinomial is just the product of the two terms and then multiplied by 2. So now we only have one equation to solve, that 3x minus 4 equals 0. And so what happens with a perfect square trinomial, if you ever have that, there's only 1 0, okay, instead of 2 when we had the difference of 2 squares. Okay? So there's only 1 0 here, and that 0 is at positive 4/3. Because we have to add 4 and then divide by 3. Just 1 0. Right? So if you have the difference of 2 squares, you're going to end up with 2 zeros plus or minus. Okay? If you have a perfect square trinomial, you're going to end up with just 1 0. So the last thing that we're going to look at then is using the zeros to find a quadratic function. So if they give us the zeros, we can find the quadratic function. So let's go back here for just a second and look at some things that we found out. Right? Oops, right here. So if I factored, okay, to linear factors, notice here I had x minus 6 and x plus 2. My zeros were 6 and negative 2. And how are the zeros compared to the factored form? What, Shelby? Okay, they're the opposites. right? Except if I have a 0, then I just have an x in front of it, okay, by itself. Same with these down here. Right? Factors x minus 6, x plus 1. My zeros are 6 and negative 1. So my zeros are the opposites of my factored form. So if I want to take these zeros here, 4 and negative 7, and find the quadratic function for them, the first thing I will do is write it in factored form. And the factors are always the opposite. So here we have x minus 4, and the opposite of negative 7 is positive 7. So the first thing I do is write them in factored form. Okay? Take those zeros and just notice that they are this was a positive 4. In factored form, it's a negative 4. This 0 was a negative 7. In factored form, it's a positive 7. And so then all I need to do is to do the multiplication or FOIL. And make sure you write f of x. What's 7 minus 4? 3. So I have x squared plus 3x. What's 7 times negative 4? Okay, minus 28. Right. So you can actually multiply the same way you factor. Okay. What are the factors of negative 28 to add to 3? Okay, 7 minus 4x. Negative 4 times 7 is negative 28. Now the one thing is that I want to note for you that there is many quadratic functions that have the same zeros, but in these problems we're going to assume that just the coefficient of x squared is 1. So you don't have to worry about all those other ones. That eventually with other classes we'll look more closely at that. Okay, any questions? So we're still finding zeros and then doing a little bit of factoring.